All right, good morning and welcome to 4.8 Applications and Models for Trig Functions. Our goal today is to work through a couple different types of problems. The first group that we're going to talk about is what's called solving a right triangle. You would have seen this already in your geometry class. So you have to fill in a few details here. I missed a couple things before I made the copies. So note for yourself that this triangle's name is ABC. Make sure you put the angles in the right corners. We're going to use our capital letters to represent the vertices. That's a convention from your geometry class. We already know that angle A is 34.2 degrees, so we'll fill that in. And they gave me here that little b is 19.4. So another naming convention is that if this is capital A up in the top corner, then little a is going to correspond to the side opposite of that angle. So opposite meaning it's not part of the angle itself. So little a would be down here. If this is angle B, then little b is the vertical leg, and little c would be my hypotenuse. So important to know those naming conventions so that you understand where to put that value. Our goal for solving a right triangle is to fill in all the angles and all the side lengths. So usually they have to give you 2 to 3 things. They have actually given you a third piece of information. I know that it's a right triangle, so angle C is 90. The easiest piece to get here would be the measure of angle B, because you know from your days in geometry that all triangles have to add up to 180 degrees. So you can take away the 2 angles that you already know, and you'll come up with your extra angle measure. So you would want to find the measure of angle B as 55.8. The side lengths are a little bit trickier, not difficult. You've already done this before, but there's oftentimes different methods. I tend to try to stick with the information that's given to me. So let's say, for example, that we want to find little a. We can only do one piece at a time. I would like to use the angle that was given, just because what if I made a subtraction error or something over here? I'd like to stick with that 34.2. I also have my 19.4, right? So to me, it would make the most sense if I'm trying to solve for A to try to utilize the 34.2 degrees and the 19.4 units. So I'm going to select the tangent function in order to do so. So tangent is the opposite leg over the adjacent leg. And I can go ahead and take out my calculator and figure this one out. I would multiply both sides by 19.4. Make sure that you've put your calculator back into degrees. I know in 4.7 we were using radians, and this multiplies out to be roughly 13.2 units. So this is my A value. If I know A is 13.2, there are so many different options now for calculating C. You could use Pythagorean theorem, you could use another trig function. You really have 2 other acute angles to use, so any trig function that involved the hypotenuse would be useful. Again, I chose to work with 34.2 and the known value, so I set mine up as the cosine of 34.2, and that would be the adjacent over the hypotenuse. This one's good to go over as well, because it gives us a chance to solve a problem where we have the variable in the denominator. Here, you could think of it as, well, I would multiply by C just to get rid of the fraction. But then, in order to get C by itself, I would still need to divide out the cosine. So the calculation will be 19.4 divided by cosine of 34.2. So go ahead and put that into your calculator, and you get 23.5. Sometimes when you use different methods, you might be slightly off, maybe a decimal is off or something. Don't worry about it, as long as you've shown your work and I can follow along. Some of the other questions involve story problems. Here we have the length of the shadow of a tree is 125 feet. The angle of elevation for the sun is 33 degrees. Approximate the height of the tree. So here's our picture. Right, here's my tree. It's pretty tall. And the sun, right, it's over here, and it's causing me to have a shadow for my tree. Right? The angle of elevation is to the sun. So angle of elevation, imagine that your eye was here. It's up towards the object you're looking at. So when they give you that 33 degrees, you need to understand that it's coming from the ground level up towards the sun. going to hit your tree, and the shadow is caused by the tree blocking the light. They did tell us that the tree was 125 feet, and so we want to use this image to try to figure out the height of the tree. Well, just like solving the triangle above, we want to use what we know, right? We have 33 degrees. We would like to find the opposite leg. We can assume that the tree is perpendicular to the ground, and we have the adjacent leg. So a good choice here, the only choice here, would be tangent of 33 degrees is equal to the opposite leg over the adjacent. You would multiply both sides by 125. So typing 125 times the tangent of 33 degrees into your graphing calculator or scientific, you should get 81.2. It's a story problem. If there's units in the question, there should be units in your answer. So we want to make sure we label with feet. All right, we'll come back with simple harmonic motion in just a minute.